Alright, let's check up. Hello everyone, welcome back to Python mini projects. So this is going to be lesson number 4. So last class we went over some installations. If some people had trouble with installing their PyCharm, installing their Pygame. Hopefully that was fixed last class. And one thing to note is this is a one-time thing, I guess, because we won't be needing to reinstall any of this, so it's just first time. So it's going to be a little bumpy at first, but that's fine. So we're going to start off and go to our tic-tac-toe game and kind of show what's going on, I guess, and explain some of the code, and make sure you guys really understand that code, because only when you understand the code will we be able to move on and make projects of our own. So let's open that up. Alright, so this is our code over here. So we used these pictures last time in order to determine like the different images that we would use. So if we were to go ahead and run tic-tac-toe, it would bring up this loading screen over here, and we would be able to get to this first stage over here. So that's what we got to last time. So we're not going to get to playing quite yet, but that is something that we are definitely going to be moving on to. So one thing that we need to look over is all these code bits over here. So we talked about last time the mouse clicking, the user click right over here. So this entire method is what we went over last time, and this just kind of talked about how the computer is able to determine where to place the X and the O. So the picture in the Python files saying error is most likely because you did not save it right, I guess. I don't know how else to say it. What I mean by this is when you come over here and you save the images, you need to make sure that these match the image names word for word. So if I'm to go ahead and open up my file explorer here, and I go into Python mini projects and make this full screen, you can see that I have all of these pictures over here. So if we go back to the code, we can see we want cross for the X, which is this one over here, and it looks like that. So once we confirm that it does look like this, next thing we want to do is make sure we get the name right. Well, all we do over here is we write the image name, but it's important to write the image type as well, which is PNG. So cross.png would be the full picture name. Now it's not always going to be PNG, so the way we can tell is over here. I believe you can also go ahead and go into properties, and it'll tell you what ending it is. Other than that, I don't think there's another way to tell, but that should get you to where you need to be. So I kept them all as PNG files. I believe these pictures over here, those were the ones that I used to name them. If you want to be more, I guess, organized, you can go ahead and delete the ones that you're not going to necessarily use. But for now, we won't need to go over that stuff, so we can go ahead and switch back to this. So that should hopefully get rid of the error. That's the only one I can really detect that could possibly lead up to the error. I mean, another one could be if you're not installing it in the right folder. That's the only other way in which I could in which I could think of how that would happen. But yeah, it should not give you an error. If you just want to test whether or not it works or not, make sure to go over here and just test the tic-tac-toe cover when you run it at first. It'll get you this picture over here. So once you see that, you know that it's going correctly. So we are actually going to go ahead and just run through the code itself. So we take a look at this, and this is initializing or starting this up. So when we go over, we go ahead and copy this name over here, and we just paste it into the search bar, and we see where in the world does this appear. So we gotta look for the highlights, and we see that we have two starting things over here, but these are actually different, as this is an actual method. We are just looking for initiating window, which is just the picture name right over here. So we can see that we load in the picture over here, and once we load in the picture, it wants to scale it to a certain size. And what this means is that when we go ahead and we normally go ahead and put in the pictures, it's not necessarily going to be the size that we want it. Now, the way that this program is created is that it needs to have certain dimensions, otherwise it simply will not fit. And so once that kind of step is complete, we can go ahead and move on. So we can see that we will define the game initiating window right over here, and this is where it will go ahead and actually show the window. Screen.blit essentially will just display whatever is happening, and it will update the display because when we go ahead and we put this picture up for the first time, it's not actually going to appear. We need the kind of screen to refresh in order for it to appear. And we have time.sleep here in order to kind of create a delay. Otherwise, it will kind of give like a weird look, and it might overrun your computer. There's no need. So this is 3 milliseconds. It's just like a super small timing pause, I guess, for the computer to slow down a little bit. Again, there's no need to go really that fast. It's tic-tac-toe. It's not like a really high intensity game. And it does screen.fill white just to set the backgrounds. So next thing that we have is when we go ahead and we run tic-tac-toe, we can notice some things. So first of all, let's run that again. First of all, when we go ahead and we run it, we can notice that we see the picture here. Now the second thing that we notice is that there are these kind of white crosses on here. So we want to make sure we understand exactly everything that's going on over here and why it's appearing. Well, the things that we want to pay attention to mainly are these 4 lines right here. So these are drawing the different lines. So these are drawing the vertical lines, so that would be these 2 lines, and these ones are the horizontal, which are these 2 lines. And that's how we get these lines over here, and that's why it looks like this. So again, these are like specific commands. There's no real need to really understand any of these, because it's just kind of a template that we copy. But essentially what these all mean, or what should be going inside these, is this is going to be the screen that's being drawn on. So in this case it's this screen right over here. We want the line color, and so line color is a variable here, which I believe is defined up here as 000, which is black. So if we were to go and Google 000 color, we can see that it is just black. Yeah, so 000 is black. And when we start adding other numbers, we can see that it adds more colors. So let's go back to the code. So it sets the color as black for the line, and then we go ahead and we get the coordinates, so where we want it to be drawn, and it says draw a line right over here. That's very important. So you can have draw a circle, you can have draw a rectangle, you can have draw a square, any shape pretty much that's a part of the method package. and the final parameter maybe being the thickness. Not entirely sure. If we hover over it, it tells us, yeah, the width, the thickness of it. So how many pixels wide this is, I believe. So this is going to be 7 pixels wide, and that's why we have 7 on the end of every single one of these. So I kind of went through a little bit already, so I want you guys to go ahead, run this program for yourselves so you guys can see what's happening and make sure you understand everything up to this point. From there, we can go ahead and move on. So hopefully we are able to just kind of run it really quickly and understand what's happening. Hopefully there weren't any questions, so we can move on to the next step. So the next step is going to be actually going ahead and checking out this next line. It looks like a very harmless line, as you know, it's one word, it's just calling a method, but this method eventually leads down to this big blob of code. So this is what's being called, or essentially that's what's going to be happening next. And what's essentially what this means is we go ahead and all of this code is going to be run now. So we go ahead and we create global draw. So this is a global variable. What does this mean? Well, the way code works is that there's certain things called scopes, or where a certain variable or method is applicable. So what global means is that it can be called anywhere. This is in comparison to any non-global variable, so class variable, method variable, function variable. So anything that's, say, only accessible within this function. So in this case, message over here, actually no, message is another global variable. Say there's actually only global variables in this, but a variable that's defined within this method that can only be used within this method. So if you were to call, say if you were to create Bob over here, and you tried to call Bob over here in this new method, it would not work. It would just give you an error. It would be undefined reference to Bob. This was never created inside this method. So adding this global keyword over here is actually really important in making sure that you know exactly what's going on. So next thing is we get the if statement. This if statement is checking whether or not there's a winner. So what does this mean? Well, you know, in tic-tac-toe, it's always good when you play that you have something that can check whether or not someone's winning. And in this case, the way it checks it is it has a variable, winner. And winner, if it is defined, means that someone has won. And that's how it determines whether or not someone has won or not. So it uses its conditions right here to determine if there is a winner. So the next thing is we want to set a font. So a font is, you know, in Google Docs, a font would be something like Times New Roman, Arial. You know, it's all just a way to present the text that we have, right? So that's what font is defining here. It's nothing more than that. So next thing is we want to set the font properties. Well, what are font properties? Well, we have a certain message over here, and this message is defined over here because we want to make sure that this the message that's being set out is properly formatted. So instead of actively just going out and printing this out, what actually happens is the program will go ahead and go, okay, I'm just going to go ahead, store this in a variable. I'm going to set up all of the properties I want. I'm going to make sure it looks nice, and then I'm going to go ahead and display it. So what exactly is happening in here? Seems pretty busy. Well, message over here is essentially whatever thing is within these if statements, right? So you can see message is equal to xo.upper plus blah blah blah's turn, because it just takes the first occurrence of it, which is right over there. Now, second thing is going to be this one over here. Well, essentially what's happening is this is a boolean, I believe, determining which way the text goes. So expects type boolean, but 0 or 1 works as well. I believe Python has some way to override it and state it as a true or false. And finally, it's going to be the coordinates. And actually, this is the color. This is the color, not the coordinates. So the color is over here, and 255, 255, 255 is also known as white. Right over here. So as we can see in the middle, the coordinates over here are 255, 255, and 255. As to why exactly they used 255 in order to determine it's white, I have no clue. There's probably some reasoning behind it, but that is essentially is white. So the maximum of each coordinate is going to be white. Oops. Let's open that up. Alright. So, finally, we copy this message that was rendered onto the board, and we create a small block in order for the text to, be finalized, to look really nice. So we use 0, 0, 0, or black here, and we enter in the coordinates. And so it's something like the beginning x and y and the ending x and y, because this is using a box to just fill up the exact coordinates of it. Again, this doesn't entirely matter, as this is all technical stuff, but this is texturing the stuff to make it look nice. So the next thing is you actually make the text box. So at this point in time, all it's doing is rendering it. So it's saying, oh, this is the message, and the color is white, as the default color is probably black or some other color. So once it goes ahead and creates this text box, it can go ahead and now actually blitz or draw out the text into the text rectangle, and then the display will update. So this was a fairly packed method, a lot of stuff going on in here. Make sure you guys kind of understand it all. I know this is going a tad fast, so I'll try and slow it down a little bit, but that is essentially what is going on so far and what we need to pay attention to. So I will give you guys about 2 minutes to go ahead and make sure you really understand what's happening. that was enough time for you guys to go over what was going on in there. So far we've gone through a lot of the technical stuff. We haven't really delved into the more I don't know, actual code. So this is just setting it up for the Big Bang, I guess. So this is the check win function. This check win function contains, well, whether or not someone has won, essentially. So what's happening here is it's a good chunk of code, about 30-ish lines, 30-40 lines. Really busy, so give you guys 1-2 minutes to kind of look over at first. What you'll notice is that it's actually in a pattern of about 7-ish lines, 6-7 lines, I think. And you'll see that it repeats this kind of sort of like a pattern about 4 or 5 times, and that means that we only really have to understand one of them to actually understand the entire code bit over here. So I will give you guys 2 minutes to go ahead and figure this out. That was enough time. So one thing that we want to take notice here is again the blocks. So we are given 3 new, I guess, global variables that we have to pay attention to. So it's important that we pay attention to these because these are going to be used inside the code here. So we take a look at this first block of code here. So I'll actually go ahead, copy this, and we can dissect this in a text window in a notepad. So you guys have to see this right over here. So we start off with for row in range 0, 3. Well, first of all, we have to pay attention to the fact that over here we're going to be repeating using the variable row. So we'll write that here, repeating using variable row. And what happens is row is repeating in range 0 to 3. So the values that it reaches are going to be 0, 1, and 2. It's not going to reach 3 because that's how the range function works, but it is going to reach 0, 1, and 2. So we notice that there's this huge if statement. Like, what in the world? Why is this if statement so long? Well, we realize something, that this is checking a certain condition, right? Well, it's checking whether or not the first, second, and third pieces in a certain row. So essentially, if we're given a board that looks like this, Actually, we'll use dots first for a clean board. So we're given a clean board, and essentially what it's checking is for every single row, it's checking whether or not these are the same value. So in this case, they technically are, right? But it also checks if the first one is not none. Well, we have to think, alright, well, for row, well, we're given 0, 1, and 2, and all of these indexes lead to 0, 1, and 2. Likewise, the indexes over here are 0, 1, and 2. So each one of these has a coordinate, right? So what it's checking is for each row. So these ones are going to be called rows. For each one of these rows, it's going to check every single one of these and check if they are the same value. So the case in which it would pass on the fact that it does go into this if statement is if it gets, say, xxx. So important numbers to note. First thing is that row is currently equal to 0. Index 0, right over here. Second thing to note is that the turn is equal to x. How do we know this? Well, x1. And in tic-tac-toe, it's impossible to win when it is your opponent's turn. So, winner is equal to board row 0. What it's checking is this spot right here. Row being 0 and the index 0. So, it defines winner as x. And the next thing that it does is it draws this huge line. What in the world is this line? Well, let's think for a second. Why would we draw a line when somebody wins? What it's doing is that it's drawing a line through these x's. So I don't know how to draw a line through stuff in Notepad, but let's pretend there's a huge line through the x's, and that's essentially what's being drawn. Now, what's being stored inside the array is different from what we are seeing. What we are seeing is simply the GUI side of things. And as a result of that, we see this line through it, but the computer, in fact, doesn't see a line through it. It just sees it as a normal thing, I guess. So that's something that's, I guess, important to note, not get confused or anything. So next thing that we need to pay attention to. Well, alright. So we notice that it has break over here. What in the world does break mean, right? What break means is essentially once we go ahead and we find our winner, well, you know, it's great and all to have 2 winners, but does it really matter? We don't want to waste more time going through this when there is only one possible winner, right? Again, following the same notion that you cannot win on your opponent's turn. So there's only one possible winner per turn. So once we find a winner, we go ahead and we determine that we have found the one and only winner. So I will give you guys about 2 minutes to go ahead and make sure you really understand what is going on here. Alright, so hopefully that was enough time to understand what's going on here. So we're going to go ahead, flip back to the code, and see how that applies in the next couple of repetitions of this whoops, pie chart. Alright, so this is the block of code that we were viewing. So now we go ahead and we view this block of code, the next one essentially. So we notice very similar structure. We have our for loop, we have our if statements, which looks like it's the same length, and then we determine the winner, and we draw a line, and we break. Very, very similar. Well, what's happening here is that it is doing almost the same thing, except when we look at the code here, we can see it says column. Well, now it's checking, do we have winning columns, right? So we were checking if there were any winning rows before, but again, we can have winning rows or winning columns. So we need to make sure we check every single possible outcome. So once we go ahead, we understand how this column is, what this column is doing. So we go ahead, we run through the code, and we notice, yes, it is checking through every single one of the columns, and it will go through the exact same procedure, and we will retain the exact same results, right? So next thing is we check for diagonal winners. Well, we notice something special here. Before we had a for loop, but now we suddenly don't have a for loop. And when we look at the code, it's hard numbers set into the indexes. So if we are to go ahead and look at our notepad over here, and we draw out our board, there are going to be only two diagonals, and they are not loopable diagonals, because the ones in which the diagonals can be in can either be in this position, right, or they can be in this position. Right, so it can be going from left to right, from bottom to top, and left to right, top to bottom. So these are the only two diagonals, right? You can say, oh, we can go from here to here to here. Well, that's also the same thing as here from here to here to here. So that's why the diagonals don't have loops, because they are indeed set indexes. So the indexes in this one would be actually we can start with this one, 0, 0, right? And the next one would be 1, 1, and the next one would be 2, 2. So we go back, look at the code, and we see we get 0, 0, 1, 1, and 2, 2. Very self-explanatory, right? And we can also see that board 0, 0 is the color checker, because it is indeed part of this. Now we notice that in this next one, board 0, 0 is not the color checker. It becomes board 0, 2. And that's because the coordinates change into 0, 2, 1, 1, and 2, 0. So we go ahead, we look at this, and we see 0, 1, 0, 2, 1, 1, and 2, 0. So it's actually in flipped order, but doesn't really matter. And that's how the coordinates work. So it's organized in the row column fashion, so or column row fashion. So that is a brief summary of what exactly is happening in this check win function over here. So it's important to make sure that we understand this, and we come to the final part of this. This final part is checking if every single box is filled, because it is perfectly possible for there to be draws in tic-tac-toe. And, well, when there's draws, it's often hard to go ahead and, use all these diagonals, these rows, these columns to figure out, is there a draw going on? Well, the simple way to figure out if there's a draw is we look at our possible moves and we see that there is 0. Or, in other words, the board is full, because we can go anywhere on the board as long as there's a blank space, right? So we go ahead, we take a look at this, and we determine something. That's all we need to do is just check if the board is full or not. And that's what is going on here. This is something known as list comprehension. It is decently advanced, but essentially what this means is that it's just running a for loop inside one line. In the end, it's just saving space. Nothing that special. Doesn't do something that we've never heard of before. It's essentially just iterating through a list and performing some sort of action. So, with that, that wraps up this final method that we're going to go over in this class. That is all the material I have for this class. We went through a couple of methods, and we will likely finish off the next 2 methods in the next 2 coming up classes. The homework, I guess, is making sure you really understand what is going on in these methods, because these methods are extremely crucial in understanding how tic-tac-toe works, especially check-win, because check-win is one of the more programming heavy methods that require you to really understand what's going on. So with that, if no one has any questions, thank you for watching, and if you do have questions, feel free to ask them. I will be happy to answer them. See you next week if you don't have any. Thanks. No one has any questions? Thank you for watching. See you next week.